Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be generating and solving exponential equations using logarithms to do so. So let's go ahead and get started following these 4 steps. If you are using a common base, it is not possible. Exponential equations can be solved using logarithms. So if, like you look at here in example 1, using a common base is not possible. I could never get 80 down to a base of 3. What we'll want to do is follow step number 1 and isolate our exponential expression. Well, that has already been done. I already have that exponential expression, the base and the power all by itself. Then we'll move on to step number 2, which is to take the log of each side. So it looks like log of 3 to the power x and log of the other side, which is 80. Step number 3 is to go ahead and expand the logarithm if necessary using our power rule. And so that means, that power of x is going to now become the value that my log 3 is being multiplied by. And then we are ready for our final step, which is to go ahead and solve. Solving for x would mean that we would want to go ahead and take both sides and divide them by log 3 so that we can isolate our x. That gives us x is approximately equal to 3.9887. There you have it, ladies and gentlemen. We are going to want to be rounding to the nearest 10,000th, just like that, as we go. Let's look at another one together. All right, so in example number 3, we want to go ahead and begin by isolating our exponential expression, and that is already done, so we're good to go. So we'll begin step number 2, which is to take the log of each side. That looks like log of 5 to the x plus 1 power equals log of 18. Then expand that logarithm using your power rule. So the power of that argument, the x plus 1, comes out front and is multiplying with log 5, and that equals log 18. Then we'll want to solve for x. That means if I go ahead, if I go ahead and divide each side by that log 5, divide by log 5, then I'll have x plus 1 equals log 18 over log 5. Now that is about, we're going to have to round here, right? That's 1.7959. So when I finish this off and subtract 1 from each side, I'll have 0.7959. And there we have it. That would be our answer. Number 5 is just ever so slightly different because as you begin that step number 1, our exponential expression is actually not completely alone yet. So what we'll want to do is subtract that 25 on each side. Then we'll have e to the 3x isolated and equal to 83. Now we're ready to move on and go ahead and take the logarithm of each side. That looks like log of e to the 3x equaling log of 83. Next, apply that power rule and expand your logarithm. So we have 3x multiplying with log e, and that equals log 83. Finally, go ahead and solve, dividing each side by log e. That gives us 3x equals log 83 over log e, which is approximately 4.4188. And if we go ahead and divide each side by 3, we'll have that x is 1.4729. So there you have it. We've gone through a few examples. Now I want to go ahead and look at the next page because some of these are a little bit different. Why don't we take a look here at, actually let's hop on down to example number 9. Because on example number 9, notice what we have. Notice what we have on each side. We have an exponential expression. So yes, our exponential expression equal to an exponential expression, but they both have different bases. So we move on to step number 2 and take the log of each of those. So log of 2 to the x plus 5 equaling log of the 3 to the x minus 2. Then once again, we use those same steps and expand using that power rule. So using our power rule, we'll have, we'll have the x plus 5 multiplying with log 2. And we'll have x minus 2 multiplying with log 3. Now, ladies and gentlemen, we are going to have to distribute here. So write nice and small so that you can get this to fit. We're going to multiply that x with the log 2 and add to that the 5 times the log 2. On the other side, x times log 3, and then subtract 2 times log 3. Now to solve this, it's going to be good to get those with x on one side. So I'm going to go ahead and subtract the x. Yeah, I'm trying to think here if there's like a best way to do this. If it doesn't matter which way, I'm just going to put the x's on the left side over here. So that's going to be, subtract that. And then I'm also going to, so minus x log 3. I'm going to subtract the 5 log 2 from both sides. So those will move so that I have my x log 2 minus my x log 3. And then I'll have my negative 2 log 3, and then minus the 5 log 2. So do you see how those that have the variable are on one side and those without the variable are on the other side? That's kind of our goal here. Now from the grouping on the left, we can go ahead and factor out that they both have an x. See that? And then we can divide by that. So we'll have that x is equal to everything that was on the right divided by the log 2 minus the log 3. And then you type that entire right-hand side into your calculator, and you will get that x is approximately 13.97. Pretty remarkable there. That would be your final answer. I want to do just one more like that so we can see that rhythm again. Look at number 11. We want to begin by making sure that we just have exponential, equal to exponential, but those bases are different. So let's go ahead and take the log of each side. And log of the other side. Then apply that property of logarithms for the power. And then we begin solving by distributing. Let's move the terms that have x to one side. And so that's going to be x log 4. We'll stay on that side. And when we move the other to the other, when we move that 3x log 11, it'll have to be by subtracting. We had on this side already the 2 log 11. And then we'll move from this side over here, we'll move this term to the other side, and in doing so we'll need to add it because it was negative. And then we will factor out the x, so we have, don't forget that 3 is still in there. And then we'll go ahead and divide. And this is so satisfying because now we come to the end and we find our value of x using our calculator is approximately a negative 1.54. And there you have it, ladies and gentlemen. That is how to solve exponential equations using logarithms to do so. If you had any questions about this, please take a moment to share those now. And until next time, stay fired up.